Objective. The objective of this lab is to learn about the two basic constant forces, normal force and friction force, and the variable that relates them, the coefficient of friction denoted by mu. In this lab, you will experimentally find the value for the coefficient of friction for a variety of surfaces. Background. When an object is in motion along a rough surface, the force of friction acts opposite to the direction of the object's motion. Materials. Blocks or plastic boxes with different surfaces, for example, sandpaper, wood, mirror, etc. A 5 Newton and 10 Newton spring scale, a 0.1, 0.2, 0.3, 0.4, and 0.5 kilogram masses. Procedure. You will perform 4 sets of measurements for 3 different surfaces. For each measurement, you will pull the block or box at a constant velocity with the spring scale parallel to the direction of motion. The reading that you record on the spring scale will give the applied force and is equivalent to the friction force that the block experiences. 1. Above the data table, write the material of the surface of the block/box and the surface on which you will be pulling the block/box. An example of step 1 can be seen here. Step 2. Using a spring scale, measure the weight of the block or box and record the weight of the block in newtons in the data table. An example of each block being measured can be seen here. An example of step 2 can be seen here. 3. You will add weight onto the block/box with masses such as 0.1, 0.2, 0.3, etc. kilograms that work well. Select 4 different masses, combinations, and find the weight of each mass, m times g, and record this as the added weight in the table. An example of step 3 can be seen here. Step 4. Add the weight of the block and the added weight and record this as total weight in the table. An example of step 4 can be seen here. Step 5. The normal force is equal to the total weight. Copy the total weight values to FNormal in the table. An example of step 5 can be seen here. Step 6. For each of the added weights, pull the block or box at a constant velocity with the spring scale parallel to the direction of motion. The reading that you record on the spring scale will give the applied force and is equivalent to the friction force that the block experiences. Record this as F applied, which is equal to F friction on the table. An example of step 6 can be seen here. Please enjoy this high-speed demonstration. Analysis. Question 1. Sketch and label the free body diagram for block/box with added weight. The force of gravity is pushing down on the box as the normal force pushes up with equal magnitude. The box is moving at a constant velocity. Therefore, the force of the spring in the positive x direction is equal in magnitude with the force of friction in the negative x direction. Graphical approach. 2. Graph the force of friction on the y-axis and the normal force on the x-axis for the 3 different surfaces. Connect the points with a straight line. 3 sample graphs with best fit lines can be seen here. 3. From the graph, write the equation for the line in terms of force of friction, normal force, and using the coefficient of kinetic friction to represent slope. the line ends up being the force of friction is equal to the coefficient of kinetic friction times the normal force. This equation can be inferred by the independent variable being the normal force, the dependent variable being the friction force, and the coefficient of kinetic friction acting as the slope, as seen on the graph. 4. Find the slope of your graph for the three surfaces. These are the coefficients of kinetic friction represented by mu k for each surface: A surface 1, B surface 2, and C surface 3. After being calculated, the quartz has a coefficient of kinetic friction of 0.75, the wool of 0.4, and the sandpaper of 0.5. Conclusion. 1. Summarize your results. Well, quartz has a coefficient of kinetic friction of 0.75, wool of 0.4, and sandpaper of 0.5. Question 2. Which surfaces has the smallest and largest coefficient of friction? Well, the largest is the quartz and the smallest is the wool. 3. How did the coefficient of friction relate to the type of surface you used? Well, the rougher the surface, the higher the coefficient of friction. 4. What happened to the force of friction when you increase the weight on the block? When increase the weight of the block, the force of friction increases due to the increase in normal force. 5. What happened to the coefficient of friction when you increase the weight on the block? The coefficient of friction is unaffected by the increase in weight. 6. Give at least 2 ways to reduce the amount of friction. 1. Lubricate the surface. 2. Wheels. Or 3. Change the surface. The application question should be answered as a class. Thank you for your participation in this online lab. See you next time.